What's up, my mathletes? This is Miss Muscarella coming at you, and in this video we're going to continue to draw or sketch angles and identify what quadrant they are in. However, we're going to be using a very different unit called the radian. So we're going to be working with radians and sketching angles. Now, just kind of reviewing a little bit from the last video, of course, you know, the quadrants are going to stay the same. They're not changing. And the direction that we're moving for positive versus negative angles, that's not going to change either. What is going to change is the unit. So, like here, where we have 0 and 360, we would have 0 and 2 pi. Where 180 and 540 are, that's going to start out 180 degrees, that's just pi. And what's half of pi? Well, that would be pi over 2. And so pi over 2, so again, this is where we're going to play with this a little bit more. At the bottom, we're going to have 3 pi over 2, and that would be if we went in a positive direction. However, if we go in a negative direction, then we're going to go the opposite. So we would have 0 here, and then negative pi over 2 would be down at the bottom. So that would be at the bottom. We would have negative pi over 2, and then over here, we would have negative pi. And where at the top of the y-axis, we'd have negative 3 pi over 2. Now, that would be really nice and very simple if all of our denominators were always 2. But that's not the case. Not the case, not the case, not the case. So we're going to have to pay attention to what the denominator is for the problems that we've got to sketch. And from there, we'll go ahead and kind of see what we've got to work with. All right, so let's go ahead and take a look at several of our examples here, and you'll see what I mean by that. And again, you know, that 2 pi, so this would be, you know, that spot would be over here. But if we're negative, don't forget, the negative sign is going around. So no difference there, and the negatives would just move around in this direction, just the same as they do if it were in degrees. So let's take a look at our couple of examples here. We're going to do 2 together, and I'm going to have you do 2 on your own. Now, the first one is a negative angle. So here's how we're going to get this started. All right, first thing you're going to do, of course, is draw your coordinate plane, your xy axis. And then the next thing we're going to do is put 0 right here. We're going to analyze the denominator. And our denominator in this case is 12. So we're going to put negative 12 pi over 12 right there on the x-axis. Now, the reason we use negative 12 pi over 12 is because if you reduce negative 12 pi over 12, of course, that would just be negative pi. And so that's another way to name that same spot. It's kind of like the same thing if you had 1/2. Well, that's the same thing as 2/4, which is the same thing as 8 over 16. They're all the same versions of the fraction. They just reduce down. So that's kind of the idea behind all of this. Now, what we've got to be able to do then is look at that negative 12 pi over 12, and look at the numerator is 12. Negative 12. What's half of that? Well, that would be negative 6. So down at the bottom, we're going to put a negative 6 pi over 12. And as we go from that quadrantal angle, and a quadrantal angle is just one that's on the x or the y-axis, not somewhere like over here in quadrant 2, or over here in quadrant 4, or quadrant 1, or quadrant 3. It's not in there. It's just right on the x, y-axis. That's what a quadrantal angle is. But when you have negative 6 pi over 12 in that spot, that tells you what you're going to need to add going around. So I'm going to add negative 6 pi over 12 to itself, and I would get that negative pi over 12. If I add another negative 6 pi over 12, then that's going to put me at negative 18 pi over 12. So at that quadrantal angle, that's the value that we would have there. Now, if I add another 6 pi, then we would be at negative 24 pi over 12. And notice here again, you know, these are some of the patterns here. If you were to take this denominator and double it, you would get the numerator. Okay, if, you know, without the negative sign, don't worry about the negative sign. But if you take 12, double it, you'd get 24. All right, now we're at negative 24, and that's well past because we had to go to negative 17 pi over 12. So when we draw it, same thing, start at the origin. Initial ray goes out to the right towards 0 and negative 24 pi over 12. And then we're going to move to negative 6, negative 12, and negative 17 would be somewhere up there. So then we would draw our terminal ray, and don't forget your other arrow. So we got 3 arrows on there. We're good to go. Now, which quadrant is that? Doesn't matter if the angle's positive or negative in degrees or radians. This is still quadrant 2. All day, baby, doesn't change. So that's always going to be quadrant number 2. That's if the degree, or if your radian measurements, if they're an even denominator. So the even denominators are a little bit easier to work with. Now, in the next example, when we take a look at example number 6, same idea as this. However, so when you got the odd denominator, same process. I'm going to draw our xy axis. I'm going to put 0 right here. And the denominator here is 3. So that means over where 180 degrees or pi is, we would put 3 pi over 3. Now we're going in a positive direction, so we're going to move around this way, in that counterclockwise direction. So when we go to do that, though, I want to think to myself that 3. What's half of 3? Well, that's 1.5. So in this top spot, instead of having pi over 2, we're going to have 1.5 pi over 3. Because if you reduce that, you would end up with pi over 2, all right? Because if we were to kind of take that 1.5 and double it, or I'm sorry, multiply it by 10, then we'd have 15. If we multiply the denominator by 10, then we'd have 30. 15 over 30, still 1/2. See what I'm saying? It's all numbers. But we're going to add that 1.5 going around. So if we start at 3, we're at 3 pi over 3, and we had 1.5, here would be 4.5 pi over 3. If I had another 1.5, this would be at 6 pi's over 3. And again, notice that the denominator, 3, the numerator is twice the denominator when I get around to where 2 pi is. All right, and that's always going to be the case all day, every day. All right, so just some patterns for you to be aware of and start thinking about. Now, if I add another 1.5 onto 6, then I would be at 7.5 pi, still over 3 though. If I add another 1.5, then we're going to be at 9. You don't have to put 0.0, but 9 pi over 3. And if we add another 1.5, then we would be at 10 pi, or 10.5 pi over 3. So, and if I add another 1.5 to 10, then I'm going to be at 12 pi over 3. And again, notice whatever this 2 pi is represented here, because there's going to be an amount, look at that numerator, it's 6. What's the difference? What's the difference between 1.5 and 7.5? Well, that's also 6. If you look at the difference between 3 and 9, if you look at the difference in the numerators of each of those coterminal angles, you're going to have 6. All right, same thing down here on the bottom, 4.5 and 10.5. The difference there is also 6. So a lot of patterns happen in here as you kind of go around and take a look at that. Now, we had to get to 10 pi over 3. So again, origin, start right there. Draw your initial side, go over to the right. And then we're going in a positive direction, so we're going to start close to the origin. We're going to go 1.5, 3, 6, or 4.5, and then around to 6, and then 7.5. Then we're at 9, and 10.5 is a little bit too far, so we'd stop somewhere in the third quadrant. And then we draw our terminal side with the arrow on the end of it. And make sure, again, you have all 3 angles. But we already said this angle terminates here in quadrant number 3. And again, be careful. Use the Roman numerals. Because if you don't use Roman numerals, you're going to get marked wrong for that, because that's incorrect mathematical notation. Now, there's 2 other examples I want you to practice. I want you to pause the video, practice it, and try examples 7 and 8 on your own. And then unpause the video, come back. And if I have you in class, make sure you ask questions. But these 2, again, take your time, pay attention to it, and draw. When you go to draw your XY axis, whatever this denominator is, in example 7 it's 18, and in example 8 it's 12. Make sure you write those, going around what all those different values are, because that's going to help develop your mathematical thinking. All right, so pause video and come back in a moment, and let's check out how you did. Booyah, baby. All right, so here's example number 7. So hopefully you ended up with an angle that looks like this. You've got all of these numbers going around, not just, the drawing, but make sure you have all the numbers listed around, because that's going to help with some things we'll do later on as well. And then this, of course, we know that terminates in the quadrant known as quadrant number 4. All right, so that's cool. So there's example number 7. Example number 8, again, on this one, you're going by 12th again. And that's similar. We already did one like that. So you kind of already understand maybe that counting pattern, because you're going to go by negative 6 pi's over 12. And when we look at this one does terminate here in quadrant number 2. So that terminates in quadrant number 2, and example 7 terminates in quadrant number 4. And again, pay attention to the patterns, because if you notice the denominator in example 7 is 18, if you double that, you get 36. You know, and that's the difference between 9 and 45. That difference is 36. 18 and 54, that difference is 36. 27 and 63, that difference is also 36. And the difference between 36 and 72 is 36. That's right, baby. So, by now, hopefully you're getting a little bit more practice and getting used to drawing angles that are in radians, sketching angles that are in radians, and being able to determine what the quadrant is that the angle terminates in. All right, thanks so much for watching, you guys. Make it a great day, and I will catch up with you later. Peace out.